As a budding programmer, you need to understand the difference between a value and a string. They're not the same, and it's important to tell them apart. In this source code, the printf statement on line 5 generates output that includes the number 27, which is really the characters 2 and 7 within the string, bound by double quotes on both sides. It's not a value, which is its own data object. The printf statement can display values, which is part of its power, but you must make two things happen. First, you must place a value into the code, and second, you must direct the printf function to display that value. I'll edit line 5. I'm adding a second argument to the printf function, comma, 27. The function now has two arguments. The first is a string enclosed in double quotes. The second is a value, 27. It's not enclosed in double quotes. The first argument in the printf function is officially a formatting string. Its contents are sent to standard output, but they're also interpreted. To direct the printf function to display the value 27, I'm replacing the characters 2 and 7 with %d. In some editors, you may see the %d highlighted. That's because it's a placeholder within the formatting string. The % is the placeholder flag, and the d represents an integer value in base 10 decimal. In this case, the function's second argument, 27. Let's build and run the code. Here's a value, 27. In this code, the value 4 appears in the output string where you see the %d placeholder. You could also replace the 2's in the formatting string as well. I'll edit it so that each 2 is replaced with a %d. Integer arguments must match up with each %d in the printf function's format string, so I'll add a 2 and a 2 here as well. You see how each %d relates to a value in the function. Save this change and build and run. And the output is text, but it uses values to display the numbers. You can even direct the computer to do the math for you. I'll replace the argument 4 with an expression, 2 plus 2. Save the change, build and run. The output is the same, but the computer performed the math, rightly calculating that 2 plus 2 equals 4. In fact, you can edit the arguments to express any calculation if you want to experiment on your own. When you do math in a printf function, it's the C language that does the math, not the printf function. Another popular placeholder is %s, which represents strings. In this code, the %s placeholder represents the string programmer, which is the second argument in the printf function. Build and run the code. And indeed, you are a programmer, but what kind of programmer are you? I'm going to modify line 5 in the code to add another placeholder and another argument to the printf function. I'm going to place %c before the %s, and I'm going to squeeze a space in between the two. %c is a single character placeholder. Now you must add an argument for the %c to represent. So after the comma here, I'm going to type a single character, big C, within single quotes. Single quotes delimit single characters, and many text editors assign the single character its own color value, as you see here. Save this change, build and run. Here's a quick list of common placeholders used in the printf function as well as in other C language functions. Each placeholder represents a specific type of data container. These are placed into the printf format string argument, and a matching argument type must appear elsewhere in the parentheses in the same order that the placeholder appears. If you need to specify a % itself in the printf format string, you must use the %% placeholder instead.